Hello guys and welcome back. Here in this video we're gonna solve another problem about forces and Newton's law. The problem is about two blocks that are connected by a cord across a pulley, but the two blocks lie now on an incline instead of hanging freely. Let's read the problem. Block A has a mass of MA 1 kilogram and block B has a mass of MB 2.5 kilogram. Block A is free to slide on an incline that makes an angle alpha 53 degree with the horizontal. So A sits on an incline and the angle between the incline and the horizontal level is alpha, which is 53 degrees. While block B sits on an incline that makes angle beta 33 degrees. So B sits on this incline and the angle between the incline and the horizontal is beta. The two blocks are connected through a pulley and a cord, so this cord connects block A and block B through the pulley. The pulley and the cord are negligible mass and the inclines are frictionless, so we don't have to worry about friction yet. So the question is, find the acceleration of block A. To find the acceleration of block A, we have to think of Newton's law, but we cannot deal with block A alone because the two blocks are connected. So when block A moves, it moves with B as well. So it means that we have to study the two blocks at the same time. So we have to study block A and block B. Now we have the objects that we want to study. We have the physical situation drawn. Now we want to know the forces acting on each block, or what does the block interact with. Let's start with block A. So for block A, we have the weight of A. It's the force exerted, or the gravitational force exerted by Earth on block A. This force is always vertical downward. It doesn't matter the orientation of A. It doesn't change with the orientation or location. It's always vertical downward. Now the other force, the block A is connected to the cord, so the cord is pulling on A, and that's TA, it's along the cord. And finally, since it sits on an incline, there is the normal reaction or the force of the incline on the block, and it is NA. Similarly, there is three forces acting on B. There is the weight of B, which is vertical downward, the tension from the cord on B, TB, and the normal reaction from the incline on B, NB. Now, we have the forces. The second step is to choose axes that allow us to switch from the vector equations to coordinate equations later on. So if we can choose one of the axes in the direction of motion, that would be the preferred choice. So I'm going to choose the x-axis along the incline. Why? Because if A is going to move, it's either going to slide down or it's going to be pulled up on the incline. So I chose the x-axis down the incline. We could have easily chosen it up the incline. It doesn't make any difference except with the sign. The second axis that I need, obviously I need another axis because some of these forces are not on the x-axis. So I'll choose the y-axis. It has to be perpendicular to the x-axis. So the only condition I have is to choose an orthonormal system. It means the axes are perpendicular. I do the same for B. So I chose the x-axis down the incline and the y-axis perpendicular to it. Now the axes that I choose for A and I choose for B are independent. I could flip them. Obviously they are not the same from the figure, you can see that, but I could choose X up the incline, Y down the plane, it doesn't matter. Now, after that, I apply Newton's second law. So I start with block BA. The sum of forces, or the net force acting on A, is equal to the mass of A times the acceleration of A. And what are the forces acting in A? We have WA vector plus NA vector plus TA vector. Same for B. I have the net force acting on B, WB vector plus NB vector plus MB vector equal to MB multiplied by the acceleration on B. Now these are vector equations. I have to project them on the chosen axes in order to get the component equations. In order to see the forces better, let me actually delete or remove the incline and the pulley and leave the forces and the axes. So these are the forces acting on B, and these are the axes that A, and these are the axes that I chose to describe A, x-axis and the y-axis. So we see that NA is on the y-axis and TA is on the x-axis, so they are not hard to project. But WA is in the middle, so I need an angle in order to do the projections. Since WA is vertical and the y-axis is perpendicular to the incline, then the angle that the incline makes with the horizontal is the same as the angle that WA makes with the y-axis. So the angle that A makes with the negative y-axis here is alpha. So now I can do the projections. So I start with the y-axis. When I project on the y-axis, first NA is in the positive y-axis, so we have plus NA. WA, when I want to project it on the y-axis, this is its projection on the y-axis. I'm projecting adjacent to the angle alpha, so I got cosine alpha, and I'm pointing in the negative y-axis, so I got a minus sign here. And of course, the magnitude of WA is just MAG. Now, the thing is, I know the acceleration on the y-axis, because as I started, I said if the block A is going to move, it's going to move on the x-axis, either up the incline or down the incline. So the acceleration on the y-axis is 0, so these are 0. So this equation doesn't really give me any new information. I know the acceleration on the y-axis. It just relates for me the normal reaction to the mass and the angle. The important projection is on the x-axis. So on the x-axis, I have first to take the projection of the weight. So this is the projection of the weight on the x-axis, or we can draw it here. This is the projection of the weight on the x-axis. It's facing the angle, so I use sine. It's in the positive direction of the axis because I chose the x-axis down the incline, so I got plus sine, and I got MAG. Then the tension, normal reaction doesn't have any component on the x-axis. The tension, TA, is all on the x-axis, but it's in the negative x-axis, so it's minus TA, equal to MA multiplied by the acceleration of A along the x-axis. Now, that's what I want to find. I need to find the acceleration of A along the x-axis. So this is my unknown. Similarly, for B, the angle that the weight does make with the y-axis is the same as the angle that the incline that B sits on makes with the horizontal. And I do the projection on the y-axis, but I already know the acceleration of B on the y-axis. It's equal to 0. And on the x-axis, I got plus MBG sine beta, now the angle is beta, minus TB equal to MA ABX. So here we have two useful equations that we can use. But there are 4 unknowns. The accelerations of both blocks are unknown, and the tension TA and TB are unknown. So I need more information to solve it, to solve for the unknowns. Now I remember that the blocks are connected by a wire. So if one moves, the other is going to move with it. But if A slides down, then B is going to be pulled up on the x-axis. So if we move in the positive x direction with A, we move on the negative x direction with B. So acceleration of A on the x-axis is minus the acceleration of B on the x-axis. That's one more relation I have. The other relation is from the fact that the pulley and the cord are massless. Since the pulley and the cord are massless, then the magnitude of the tension on one side of the cord should be equal to the tension in magnitude of the other side of the cord. So we have TA equal to TB. So what I'm going to do is I'm going to use this equation to find TA, this equation to find TB, and then I can equate these two. So from the first equation, I have TA equal to MA G sine alpha minus MA multiplied by AX, or the acceleration of A on the X direction. Same for TB, it's MB G sine beta minus MB ABX. I equate these two, then I also replace ABX by minus AAX. I group AAX on the same side, so here we have AAX. I take MA and MB common, and on the other side I have MA G sine alpha minus MB G sine alpha. I divide both sides by MA plus MB, and I got the acceleration of A on the x-axis is equal to MAG sine alpha minus MBG sine alpha over the MA plus MB. So let's see if that makes sense. The TA and TB, if we look at the system as a whole, TA and TB are internal forces. The normal reaction does not affect motion because the only possible motion is along the x-axis. So what matters for us is the component of WA on the x-axis and the component of B on the x-axis. So the component of A on the x-axis pull A down, so it pulls A in the positive x direction. So that's why we have plus MAG sine alpha. And the component of B on the x-axis pulls B down, so it pulls A up, so it is minus MBG sine alpha. Now that's the forces that are pulling on that, but we have to divide by the total inertia of the system. The only thing that has inertia are MA and MB, so we have MA plus MB. If we put now the numbers that we had in the given for MA and MB and alpha and beta, we got AAX as minus 1.6 meter per second squared, and of course we know AAY is 0. So what's going to happen to A is that A is going to accelerate in the negative x direction, so it's actually going to accelerate up the incline. Well, of course it depends on what it was doing at the beginning, but if we start from rest, it's going to start going up and speeding up upward. For B, if we look at B, the difference between acceleration of B and A is that they are opposite to each other. So acceleration of B on the x direction is minus the acceleration of A on the x direction. So we got MBG sine beta as plus minus MAG sine alpha over MA plus MB. So it is going to be plus 1.6. So B is going to accelerate in the positive x-axis or down the incline. Thank you, and I hope you find this helpful.